Oh, let's go back in time. Do you remember this movie? This is the movie Back to the Future, where Michael J. Fox is in that beautiful vest, and I think it's Christopher Walken in the car, and they travel back to 1955 in that hot rod, that DeLorean. So we want to travel back in time a little bit. So back in time, when we wanted to find the zeros of this polynomial, we had a problem. We couldn't just grab our technology and graph it. So how did you find the zeros? And, I mean, do you start like randomly guessing? Well, that's great, but what if the zeros are like 3/4, 7/2? Are you really going to guess some of those numbers? Eeh. Well, that's where this idea of the rational zero theorem comes into play. So the rational zero theorem says that any rational roots of the function are in this form. We're going to say P over Q, where P is a factor of the constant term, the 4 at the end, and Q is a factor of the leading coefficient, the 2. So the possible rational zeros for here are plus or minus the factors of 4 divided by the factors of 2. So if you think of the factors of 4, it's 1 times 4 and 2 times 2. And the factors of 2 are just 1 and 2. So some of our possible rational zeros, we'll say, if they're rational, they could be, and watch how I'm going to do this. I'm going to start with the different factors of the numerator and keep just one factor in the denominator. So it's going to be like plus or minus 4 over 1, or plus or minus 2 over 1, or plus or minus 1 over 1. So I did all the factors of the numerator with just the factor of the 1 on the denominator. It could also be plus or minus 4 over 2, plus or minus 2 over 2, plus or minus 1 over 2. Those are all the factors of 4 divided by 2. So if we kind of simplify these a little bit, some of these factors are, let's see, plus or minus 4, plus or minus 2, plus or minus 1. But notice that 4 over 2, we already have that, it's 2. And 2 over 2, we already have that, it's 1. And the one that we don't have then is plus or minus 1/2. So if there are rational zeros, we can choose from this selection of zeros. So at least we narrow it down a little bit. So maybe what we'll do now is we'll use some synthetic division to determine some of those zeros. If you want to pause the video here and do some synthetic division to try to get some of the zeros, that would be great. All right, so where do we start? Who knows? Well, why don't we try maybe 4? So let's see, if we try 4 as one of our zeros. Remember, we write down the coefficients. I think our coefficients were 2, -5, -18, +2, and +4. And then we go through our synthetic division. Let's see if I bring down the 2. 4 times 2 is 8. That gives me a 3 when I combine. This gives me a 12. There's a -6. Okay, that's not too bad so far. This is a -24. I don't like where this is going. And yeah, 4 times -22 is -88. And that's yucky. Ugh. So what I know is 4 is not a zero of that function. Well, maybe we'll keep trying some other numbers. What if we try like maybe 1/2? So let's see what 1/2 does. And I'm thinking 1/2 might be one of the zeros because the leading coefficient is 2. So that means typically it has a factor that has like a 2x with something. So maybe that 1/2 might work for us. Let's see, I bring down my 2. Half of 2 is 1. -4 there. Half of -4 is -2. That's going to give me a -20. Half of -20 is -10. That's going to give me a -8. Oh, look at this. Half of -8 is -4. That's a 0. Cool. So I know one of the zeros then is x equals 1/2. That's cool. Let's keep trying. Maybe I'll try some of these negative numbers. I'll try like a -2. And let's see what that looks like. Need a little bit more room here. Let's see. Bring down my 2. Negative 2 times negative 2 is, or times 2 is negative 4. There's a negative 8. Here's a positive 16. That gives me a negative 4. Oh, look at this. Negative 2 times negative 4 is positive 8. I get a 0. That's really cool. This tells me that x equals 2 is another one of my zeros. And now I got it down to, negative 2. And now I got it down to a polynomial or a trinomial. So now I can factor 2x squared minus 8x minus 4 equals 0. And remember, I can factor out that GCF of 2. So now I have x squared minus 4x minus 2 equals 0. Okay, so now I'm thinking these two terms have to be multiplied and equal to 0. So that means that either x squared minus 4x minus 2 equals 0, or 2 equals 0. Well, 2 doesn't equal 0, so I'm going to forget about that. So if I solve this, and I'll let you do the quadratic formula for it, I believe we get answers to be x equals 2 plus or minus the square root of 6. All right, the square root of 6 is probably right around like 2.5. So if I think of some of these numbers, maybe it's about 4.5. 2 plus 2.5 is 4.5. And then maybe 2 minus 2.5. Maybe it's about negative 1/2. Maybe some of those are my answers. So my 4 zeros that I've got 1/2, negative 2, 4.5, and negative 1/2. Nice. Well, let's see if we can sketch a graph of this then. I know a couple things about this graph. I know that I got a bunch of zeros in there. I think I gotta go out to 4.5, so we'll go out there to 5, let's say. So some things that I know. I know that one of my zeros was 1/2. I know that one of them was negative 2. I know another one was like positive 4.5. So maybe right around there, somewhere around there. And then those around negative 1/2. Sounds good. Those are my 4 zeros. X equals about negative 1/2. We'll make that the approximate symbol. We got about 4.5. And I know that we got x equals 1/2. And I know we got x equals negative 2. I also know that my y-intercept, if I remember correctly, I think the y-intercept is going to be at the point 0, 4. Good to know. That's the constant term. We'll make a dot there. And let's think what this graph is going to look like. They're all singular roots. They're all multiplicity of 1. So it's an x to the 4th equation. It's going to come down. It's going to turn around. It's going to go up there. Might come back down, something like that. Might go back like that. Yeah, that's about the best I can do right there. Can't really do too much more than that. We're going to need some other tools of math to get some things like these turning points. But that's pretty good. I'm good enough right there. So let's continue. Here's another function. Let's see if we can first find the zeros of it. List your possible rational ones, and then see if you can find the zeros. Pause for a few minutes. I gotta go get a drink of water anyway. All right, let's see if we can find some of these possible rational zeros. My possible zeros are going to be factors of my last term divided by factors of my first term. So the factors of 18 are 18 and 1, 9 and 2, 6 and 3. All those different factors. The factors of my leading coefficient, that's just 1. So really my possible factors are just plus or minus 1, plus or minus 2, plus or minus 3, 6, 9, or 18. So if you got those and you have yet to find the zeros and get it in factor form, give it a shot. Please do. All right, where to begin? Where to begin? I'm going to try number 2. So let's see, if I bring down my 0, if I write down x equals 2, let's say, and I write down my coefficients, -9, -18. Let's see what we got. Bring down my 1. There's a 2 and a 1. There's another 2. There's a 9. Ooh, this is kind of nice. There's an 18, so that's a +9. There's another 18. There's a 0. So one of my zeros is x equals 2. What else should I guess? Why don't I guess -1? Let's see what -1 does. Bring down my 1. -1 times 1 is -1. There's a 0. Okay, I got a 0, but I didn't finish my synthetic division, so don't stop there. -1 times 0 is 0. That gives me a 9. -9, that gives me a 0. Okay, so I got my 0 there for my remainder. So that means another solution, another 0, is x equals -1. Awesome. Take a look at the polynomial I have left. It's x squared plus 0x plus 9. All right, so then what I have to do next is I have to solve x squared plus 9 equals 0. So I'm going to solve that by square root, so I'm going to subtract the 9 from both sides. I take the square root of both sides, and I get plus or minus the square root of -9. Ooh, baby. How about plus or minus 3i for that one? And you're saying, whoa, where did that come from? It came from the fact that we have 2 other roots that are imaginary. Remember, because it's an x to the 4th polynomial, you're going to have 4 roots. There's going to be 4 zeros. Not all of them have to be real zeros. So this is a function that only crosses the x-axis twice. So if we're going to sketch a graph of this thing, let's see, we'll put our graph like right here maybe. And I'm going to move my y-axis down a little bit, because my 2, I know that those 2 values are 2 and -1, but then I'm way down here at -18. So again, I think it's an x to the 4th. So this is going to kind of look almost parabolic-ish. It's going to come down, it's going to go through there, it's going to go back up there. That's about the best I can do right now. The imaginary roots don't really play a role in the graph of it, but they are roots of the answer. They are solutions. So that's how we used to do it back in the day. Aren't you appreciative of the technology that you have?